Going on with our reading. As he looked at the data, Mendel noticed an interesting pattern. Side note, in science, you're going to notice that there are lots of things dealing with patterns going on. If he calculated the ratio of the two traits in the third generation, side note, remember this is the parents are crossed, the pure parents are crossed to a first generation, like Sky and Poppy are crossed. They produce their first generation, which is, the second generation, which is Ocean and Blue. Wait, no. Who is Ocean's? I'm having a mind fart. Ocean's counterpart there. And then they go on to have children, and that's what our third generation is. He obtained a ratio very near to 3-1. Again, 3-1. This is a ratio. It's kind of like a pattern, or it's kind of like a fraction. For every 3, there's 1. For every 3 slices of pizza that are mushroom, there's 1 pepperoni slice. Okay, that's what a ratio is saying. In this case, for every 3 wrinkled, there might be 1 smooth. For example, for seed color, the ratio of yellow to green seeds can be calculated as 6,022 yellow to 2,001 green. Oh, look, they're pulling those numbers directly off of that table above. And if you divide that, or if you reduce it, remember math, reducing fractions, okay? 2,001 goes into 6,022, 3.01 times. Okay, so we're looking at common denominators and fractions and oh my math. So this fraction is the same as 3.01 yellow to 1 green, or approximately 3-1. This is almost exactly a 3-1 ratio of yellow to green. Side note, science, it's more like real life. You're never going to get exacts, okay? There's always going to be random events, random mutation, random things that happen. So it might be slightly off. So you have to look at approximate going on. This means that for every 1 green-sided plant, there were almost exactly 3 yellow-seeded plants in the third generation. You can also express this in terms of the fraction 3/4 and 1/4. Okay, so 3-1, 3 yellows to 1 green is the same as 3/4 to 1/4. Mendel concluded that not only did the green-seeded trait reappear in the third generation, but the probability of the third generation plant having a trait was 1/4. That is about 1 green-seeded plant for every 4 plants produced overall. He found the same ratio with several other characteristics. The 3-1 ratio he found for all of these different characteristics was the clue to how parents' genes combine in their offspring. Based on his analysis, he proposed the following. First, each trait that appears in the second generation is the dominant version of the characteristic. The trait that is hidden is called the recessive. Okay, so there's 2 different forms. Side note, dominant and recessive. That's what Mendel is saying. Dominant will always be expressed when it is present. Recessive will be hidden if there is a dominant present. Okay, Mendel also found out that every plant has 2 copies of the gene for each characteristic. These 2 copies are called alleles. The evidence suggested there was more than 1 copy of the gene for each characteristic in each plant, so the simplest assumption that would work was to have 2 alleles. We know now that these alleles, they have 2 copies as a side note because 1 comes from the mother and 1 comes from the father. Going on. Each pea plant receives only 1 allele for each characteristic from each parent and ends up with 2 alleles of its own. And this ties into the previous one. He then used these ideas to argue that the 3-1 ratio is exactly what is expected in the third generation for every plant characteristic. In the earlier activities, you explore this proposal using discs and coins as models for genes. Side note, you also did this when you explored the Punnett square activity in Activity 5. Go ahead and answer the stop to think questions number 3. Explain how the model using coin tosses in the activity gene combo compares with Mendel's explanations for his results with the pea plants. For those that did not do activity 4 or didn't do it in time, we had 2 options, heads or tails, and we flipped coins to try to come up with combinations. How would that represent parents? Using a coin, how would that represent parents? Or using 2 coin flips for each offspring, how would that represent parents? Question B. People often think of mathematics as important in physics, which is like things dealing with atoms and light and, the solar system, and chemistry. That means when you combine things together and get reactions and stuff. But it's also important in many fields of life science or biology. So explain how Mendel used mathematics in his work. So what kind of math have you had to use? What kind of math did Mendel have to use? Go ahead and stop, answer these questions, read the rest of it, and then go on to the analysis.